Ladies and gentlemen, you are welcome. So in today's video, we are going to look at the concept of Avogadro's law. So what is Avogadro's law? Avogadro's law is a law that states that the equal volume of gases at the same temperature and pressure contain an equal number of molecules. So meaning that the equal volume of gases, when the temperature and pressure remain constant, they contain an equal number of molecules, meaning that here the law is trying to show the relationship between the volume of gases as well as their number of molecules when the temperature and pressure remain constant. So meaning that from this we can clearly see that the law is trying to show that the volume and the number of molecules are directly related. So that is why in Avogadro's law is a law that's trying to show that V is directly proportional to N, meaning that when volume increases, then the number of molecules will increases. And as the number of molecules increases, then the volume will also increase. So therefore, they are directly related. And don't forget that, ladies and gentlemen, whenever we have proportionality, then we introduce constant. So that is why here this implies that this is the something to say V is equal to Kn. So the K here stands for constant, while V here stands for volume. So therefore, we can now make the K subject of the formula where we are going to have V all over N is equal to K, which implies that we can now say V1 all over N1 all over N1 then is equal to V2 all over N2. So this is actually the formula that we are going to have. So at the end, we are going to have this formula, which says V1 all over N1 is equal to V2. So this is the formula that trying to show the relationship between volume and the number of molecules when the pressure and the temperature remain constant. So from here, ladies and gentlemen, we can see clearly that this principle was first formulated by a scientist called Amedeo Avogadro in the early 19th century. And of course, from here you can see the picture of the Amedeo Avogadro. So it is a fundamental in understanding the behavior of gases and their relationships in chemical reactions. So let's look at how we can drive this equation of Avogadro's from ideal gas equation. So whether from the general gas equation, we have CV is equal to nRT. So now, how are we going to drive the equation from there? So whether from here we can see clearly, we can now say V all over nRT divided by the pressure. And of course, we can divide by 2 by n. So we can now have V all over n is equal to R is equal to RT all over C. And all the R is constant, the temperature is constant, and the pressure is constant. So therefore, all this will be presented as K. So therefore, we are now going to have V all over N is equal to K. So this is how to derive this formula from the ideal gas equation. So then the next thing is, this is actually a graph showing the relationship between volume and the moles. So you can see clearly from here, as the number of molecules increases, the volume also increases. As the volume increases, then you can see that the moles also increases. So that is why we have a straight line graph. So now let's look at an example. So examples, or before these examples, ladies and gentlemen, I also want to say something very important. So if you actually want to know the exact number of particles that make a particular molecules, then you use Avogadro's number. So to know the number of particles that are present in a particular or in in an atom, then we use Avogadro's number. And this Avogadro's number is represented as Na, which is the same thing with 6.02 times 10 raised to the power of 23. So this is Avogadro's number. And if you also want to know exactly the number of particles that are present in a particular moles or in a particular molecules, then you use a formula which says mole. Mole is N, so N is equal to, you can now say the number of particles, divided by the Avogadro's number, which is 6.02 times 10 raised to the power of 22. So you can use this to calculate the number of particles that are present in a particular number of molecules. So, of course, this is the graph that I just explained. So let's look at an example. So we have at 25 degrees centigrade and 2.00 atm. So the pressure and the temperature are constant. So a sample of 6.0 liter holds 0.5 moles of a gas. So we are now going to drive this. So we have V1. Let's bring the data out. So we have V1 as 6.0 liter. And then we have N1 as 0.5 mole. And then the next one is, so what is the final volume? That is V2 is unknown of the gas if 0.25 moles more are added to the same pressure and temperature. So now we are now going to have N2 since it is actually added already on 0.5. So we are now going to say 0.5 plus 0.5 plus 0.25. And this will give us a total of 0.75 mole. So we have this. So we now have our N2 and then we have our N2 as 0.75 mole. So then the next thing now is to calculate the V2. So to calculate V2, we use the formula V1 all over, V1 all over N1 is equal to V2 all over N2. So to make V2, so the formula, so we now have V2 is equal to V1 N2 divided by N1. And this will give us V2 is equal, so we have this formula, so the V is 6.0 and then the N2 is 0.75. So we have 6.0 divided times 0.75 divided by N1, which is 0.5. So you will now use your calculator and get the final answer. And how do we calculate this? So now just say 6 times 0.75 times, divided by 0.5, and that would give us the final answer. So the final volume is 9. So we now have 9 liters. So this is the answer. So ladies and gentlemen, this is how to gauge the number of volume here. So the next one, we can have also another question here. A function takes away half of the volume of a tire with 10 moles of air and a 40-liter volume. How much air is left in a tire that has been depleted? So I think, ladies and gentlemen, this question is simple. So you see, a function takes a half of the volume of a tire with 10 moles of air and a 40-liter volume. So how much is left in the tire that has been depleted? So see here, we are going to calculate the N2. So a function takes away half of the volume of a tire when 10 moles of air, with 10 moles of air and a 40 volume. So you can see clearly here, ladies and gentlemen, the volume, the initial volume will now be Therefore, now the initial volume is going to be, the initial volume that is V1 is going to be 40 liter. And then the initial mole, which is M1, is going to be 10 mole. And then the V2, because the function takes away half, so the V2 half, that is the half of the volume, which is going to be 20 liter. And then the N2 is unknown. So we are now going to calculate N2. So we now use the formula that says V1 all over M1 is equal to V2 all over N2, which at the end, we are now going to make N2 subset of the formula. So the N2 is now going to be V1. So it's now going to be V2 M1 all over V1. So you see the V2 is 20 times the N1 is 10 divided by V1 is 40. So this one will now take care of this. Then we now have 20 divided by 4. So we now have 5 mole. So the answer is 5 moles. So this is this, ladies and gentlemen, this is briefly on Avogadro's law, and I hope this video will be very interesting and important. So you should watch and actually join the YouTube community. Thank you very much. See you next time.